Life safety plan and code analysis, walking through the template that the standards committee came up with. So what you see on screen happens to be Voight, but it's the format that we've come up with for the new code analysis. So all the code section here, it's broken out, if you wouldn't mind zooming in on it. In the past, we've been a little bit fragmented, and there were no physical Chapter 5, Chapter 4 headings, so whoever happened to get into the model, lay out the life safety plan. Well, this piece seems to work well over here, and this piece really fits here, and you put the puzzle together, and your code analysis is just all over the place and hard to follow. So the first thing that we've done here is really broken it out by the base IBC codes, and we'll get into NFPA and how all that works out too. But if you follow this logical format, it'll walk you through the code, and it's also going to tell you the key parts of your building that you have to discover before you move on. So what you have in your hands, the first 4 pages, is a process document, which you can actually take back to your desk. And with this template, you can follow line by line exactly what step you should be doing and when. The rest of the pages are just more information so that you can see them as we're going through the presentation. So just diving in the top here, pretty easy stuff. I'm not going to dwell on the things that are really just taken from one table or another table. We're going to spend a little bit more time on actually how you do the calculations and what important trade-offs kind of arise depending on which path you take. So the first section, project information. I don't see it on a lot of the projects, but it's going to be the new standard. With all the energy conservation issues and whatnot, it's up to us to determine your climate zone, your risk category, which we can all do, just pulling it right from this section of the code. This happens to be Florida, which is IBC based, so you'll be able to find it basically, and you may have to update a couple sections. And then the next sections are site class and seismic design category, which is a little Greek to a lot of us. Structural engineer really needs to determine that, but we have to prompt them so that we know if we have any seismic requirements that we have to design to. Next section is governing codes. No further explanation needed. Basically, it's up to you to determine what your base code is, what your state modifications are. In this case, Florida has their own fire protection code, which then triggers NFPA. So it's up to us to really determine what your applicable codes are. So the first step in carving out a building is your use and occupancy, and it seems pretty straightforward. Go in and determine, is it an R2, is it an assembly, is it a business group. In this case, we have an R2, A2, A3, a B, and an S1, and I'll get into how that was broken out a little bit later. You assign your primary occupancy, and then if NFPA 101 or 1 are required, you have to do the same thing. And then be careful because these occupancies are slightly different than IBC, and they trigger different requirements that you have to follow through. In any case, or in all cases, we've listed out. These are, we call them breadcrumbs, so you know exactly where to go. And if you're working on the 2018 version, and this is, that happens to be 2017, but it doesn't quite line up exactly, you can use this as a starting point and know that, well, you're going to be somewhere in Chapter 3, and you just fine-tune it from there. And the idea is that everybody should go and update those references, and as you're doing that, just briefly skim over that section of code. And that's how you can catch any discrepancies or new changes in the codes, and become a little bit more familiar with what you're dealing with. So the next chapter would be Chapter 4, special detailed requirements, and this is simply opening up the section of the code and just paging through it to find out what's really applicable in your project case. There are requirements for high rises, atriums, parking garages. When we start doing skilled nursing, I2, I1, R2. In this case, and I'll walk you exactly how I did Boynton, they have a state-specific section for swimming pools, and then public food establishments, and all the others don't really apply. Now, get into some of the more fun stuff. And by nature, I guess some of the boring stuff. When you first start out, you have to figure out, well, how tall can my building be? What is it made of? How big can it be? And the first step in that is to look at your fire resistance ratings for the building elements. And I actually have this as your first page. It's document 01 at the back of that, just so you can see it. But when you start, and at any point, if anybody has any questions, please just jump in and stop me and I'll explain a little further. But this is some of the more basic stuff. You have to have an idea of what your building is. And briefly, for those who may not just yet know what these mean, type 5, 4, 3, 2, and 1 are your different types of construction. And then basically you have a type A, which would be sprinklered, pretty much what that means. And a type B is non-sprinklered, so protected and unprotected. Type 4 is going to be your wood construction. You can pretty much use anything you want to, wood frame. And of course that keeps your building size very small because the thing will burn down. Type 4 is heavy timber. Type 3 is kind of a mix between the two. It's a non-combustible exterior wall, and then whatever you want on the inside of the building. Type 2 is all non-combustible, and type 1 is basically bomb shelter, usually just out of concrete, and pretty heavy-duty stuff. So the first step, in the case of Boynton, it's CMU walls and concrete reinforced cast-in-place slabs. So we really could do it as a type 1 construction, but the implications of just going right up to the higher construction category or type is that you've got 2 and 3 hour ratings that you have to deal with. So in general, you want to start with the lowest classification that you can. In this case, because we have CMU bearing walls and we happen to have metal stud inside, we could do either wood stud inside or non-combustible metal. The owner chose metal. I would still start out as a type 3A because that's going to keep my fire ratings to the minimum, and it's also going to keep the costs as low as we can. So once you've, established or picked your first category, let's just say a 3B, in the case of Boynton and a lot of other projects, especially if you're doing skilled or assisted, you end up having to deal with NFPA 101, which has a whole nother system of classification. So if you actually go down, they have type 1, 2, 3, 4, and 5, kind of similar. But what's all this? Type 222, 111, 000. These classifications don't quite line up with IBC. So if you go back to this one, this basically tells us that we picked an IBC type 3B, which corresponds to a 3200 over here on NFPA. And the ratings are basically the same, but there are some nuances that you'll learn over time. So that's your first step. You decided what you think your building wants to be, and now we can figure out how tall it can be and how big it can be permitted to go. So if you open up O2.
Quick question.
Sure.
So NFPA will be jurisdictional specific, correct?
So a lot of times for licensing, NFPA will kick in. Also, a lot of times for state fire marshals, in both the case of Georgia and Florida, they have their own fire code, which mandates NFPA 101 and 1, which is their fire code. So most of the stuff that we do If it's just straight residential R2, it's just IBC. It's not as often that NFPA gets triggered, but you've got to look on a state-by-state basis to figure out, like Jersey, it's not triggered for your Lantern Hill, but if you were going to do an I2, it would get triggered at the state level through affairs. So it's really going to vary. And I can't give you a nice answer exactly when it is and isn't. It varies. So the next step is to just get a general sense of, well, I know we went through conceptual design and we've got a 100-foot tall building or a 50-foot tall building. So this table is where you're going to start. You've already established the type 3, type 3B, and you find your occupancies, which we already picked out. In the case of Boynton, it's a couple A's, a B, an R2, and an S. So you find your occupancy, sprinklered or non-sprinklered, you come across. Tells me I can go 75 feet high with an A and a B, and in this case, 75 for an R. So that's your first pass. Everything's good, so we can move on. And this is really just pulling it straight out of the table. You just have to know where to look. The next page.
The next page.
Yep. Very similar. This is going to tell you how many stories. This one will catch a lot of people, depending on how you carve out the space, because now for a 3B, now it tells me how many stories I can go. So for my A2 and my A3 occupancies, I'm limited to 3 stories. So I got to make sure, like the case of Buckhead, where there's amenity space up on the 8th or 18th floor, that's a problem. Yep.
So you tagged on your first code sheet that it was R2 primary. When you're just determining these types of things, even though your primary is one thing, do you default to the most conservative?
Well, we'll get to this. I'll give you a quick answer and then we'll dive a little bit more into that. So if you have a 5-story building and it's all primarily an R2 occupancy, that's your base occupancy. But it's not uncommon to have a restaurant on the first floor, all these amenity spaces. So those are your A2s and your A3s, and you just have to be aware that you can't throw that space any higher than the 3rd floor. It's just not permitted if you tried to. And there's other things we'll talk about, separated and non-separated occupancies, that'll come back and bite you if you're not careful here. So our primary occupancy, sprinkler, 5 stories, we're good to go. It's really not any more complicated than that right there. If you wouldn't go 03. So the next step is to figure out how big can this building be. You have to get your allowable area per occupancy per floor based on your construction type. Well, in order to do that, you have to take a side step, and figure out what kind of frontage, where's your building built, how much open space is around it, all that good stuff, because that's going to give you an allowance to increase the size of the building. So I'm not going to go too deep into this, just other than to briefly explain. You have these calculations in the pamphlet. Could you go to 04? So this is actually in the model, and those equations that were on the last page are stated right here. And you have to find your weighted average of how much open space you have that will then plug into your frontage increase calculation. So for Boynton, actually, once you go to that area calculation in the Revit model. So we have these, or the way I do it, is to actually have the Revit model go up, and it's a dedicated view somewhere off to the side, just area calcs in one of the working views. And so I've taken the perimeter and started out with the floor slab, and just you edit the floor slab, copy out the line work, paste it into a filled region, and then you can modify it from here. Now, if you notice, this has all sorts of zigs and zags in it. We're trying to figure out how much open space I have in front of it. So clearly, this little piece here doesn't do anything. So you take the perimeter, and I'll show you that one in a second. But you copy this out, and then in terms of calculating frontage, you don't have to waste time calculating every little piece. You just draw a straight line, because basically you get this straight line that's got over 30 feet, that piece over 30 feet, that piece over 30 feet, and these little pieces don't mean anything. So just keep it simple. And so what you have to figure out is you have to be at least 20 feet, but over 30 feet in order for it to count. So this perimeter counts. And now in here, I'm only 28 feet apart for 33 feet. So that has to factor into this calculation. And then here I get 26 feet. That's 10 and a half feet, and so on and so forth. I get 0 because it's right up against another building. And then this is less than 10 feet, so I can't factor that in. So when you work out the math, you have the total perimeter, and you subtract out 183 feet is this length through here, which is dead space, and 186 feet on this side. What you end up with is a total perimeter of 1,200 linear feet, 974 is on the public way, greater than 20 feet. So if you go back to that 03,
304.
this one. So that's where all these numbers come into play. So we've taken 915 linear feet, that's 30 feet around the perimeter. And then you add in, I had a 59-foot section that's only 22 feet. And then you add those together, divide by your total perimeter that's on the open space. And when you work out the math, it gives you a factor of 29.5 for this half of the building, 29.8 for this half of the building. Pretty exciting stuff, right? But this is one of your biggest lifesavers, because this calculation, you'll see in a minute, dramatically increases the size of the building that you can have. Any questions on that part? Okay.
Are you doing that manually, or do you have,
Oh.
for example, Excel?
If you go back to the model, so scroll down here. I take a shortcut. We always will have a slab in there. So I'll start out with that slab and then edit the slab, copy the line work out, and then if you go down, I come up with this perimeter. So I didn't have to manually go around and click everywhere. It goes a little bit faster. But now to figure out this whole perimeter, what you do is highlight that filled region and edit, boundary, copy all that line work, just copy it, and then close out and create a floor slab to your right.
Yep, right there.
Just paste in place and then close that out. So I've taken that line work, and you can work backwards from the slab to the floor. If you already have a slab, that the problem is if you take this slab, sometimes there's holes in it because of elevator pit and stairs, and it's you want to be more accurate, and you also want to save this calculation because you're always going to come back to these things and have to tweak them, and you might as well start over again if you didn't save your line work. So if you highlight that slab, you might have to tab. There you go. It gives you 1,296 linear foot perimeter without having to manually go around and calculate that. So if you go back up now, 1,296, there's my 1,296 linear foot, and the only thing I had to do now was subtract out these oddballs, the 168 feet, 31, where I didn't have enough of a perimeter, and that total was 1,006. So it's going to do some math, but if you can figure out a way to automate it, great. But anyway, that's what we ended up with, our weighted open space factor, and I'm running two buildings here side by side, and we'll get to why I did that. But 29.5, 29.8, you simply take those numbers and plug in the F and the P, the the full perimeter and or the frontage perimeter and then the full perimeter. So 974 divided by 1243, you take out the 0.25, blah, 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 work out the math. Your frontage increase factor is 0.52, and it just so happens to be the same for both. So now we start really figuring out how big a building is. And you all have, it's document number 5, which is your allowable open space. And I cut a lot of the other sections out just so, because we're dealing with 2, 3, B, and R2. And you take your calculations, and let's just say we're doing an A. We're working on the A2. We've already decided we have a 3B, and it's a sprinklered multi-story, so it's not complicated. Just pull out the 28.5, and you keep on going for each one, 28.5, 48,000, whatever that happens to be. If you go back to there you go. So here's our equation taken right out of the code, and I can go in more detail on any of this if somebody wants to, but like I said, it's pretty dry stuff. So our primary occupancy is an A2, just using this formula, and you have the formulas in there too for reference. It's your tabular area, which is what I just showed you. In the case of R2, this example was run with a 2A, which is why this number is different than what I just told you. But if you find it in that chart, it'll say 72. And then you take your non-sprinklered value, which you'll find to be a 24, and then multiply that by your frontage increase, which we just determined is a 0.52. When you work all that out, instead of being stuck with 72,000, you could go up to 84,480. And you have to do that for all 4 of your occupancies. So now I'm going to actually break. Well, let's go into document 6 first, and then I'm going to break an LBA rule and ask you all to get your phones out. Okay. So I've shown you basically how to figure out the size of your building, but didn't tell you yet which calculation you should be using. And that's really going to be how you decide to carve your building up. Now, what I mean by that is what Aaron asked. You had an A2 occupancy. It's only allowed to be 3 stories high. So if I have a 5-story building, do I have to separate that occupancy out? If I'm stuck at 3 stories at that A2 occupancy, then yes, I have to separate that occupancy out. So I'm no longer a single occupancy. Well, I'm not a 1-story building, but let's just say you were. It was all an I2 or an R2, 1 story. That's your simplified calculation. If I'm like a Lantern Hill building 3 or 4, which is 5 stories, just residential, I'm a single occupancy, multi-story building. And most of ours are going to be a mixed occupancy, multi-story building, which is the calculation that I just showed you and what Boynton is run on. So you have to determine which compliance path you're going to take. And part of that's going to be a gut feeling that you learn over time, because there's different trade-offs that if I have an A2 and A3 and I have to separate that out, well, what about the B or the S1? Do I have to separate that out? Well, no, you don't have to. You can have a combination of part of a building as a mixed occupancy, separated use, and another part that's non-separated. So if you wouldn't mind going to G110 in the debit model, and scroll down, so we can show the floor plan. So in this case, all this crosshatch area is a B occupancy. I'm sorry, this is the A3 occupancy. And the pluses is an A2. This diagonal crosshatch is a B. And you can see where I've got some fire barriers here to separate the B from the other occupancies A2 and A3. Now I didn't have to do that, but if you choose not to do that, one, you have to make sure your A2 isn't too high in the building. I mean, that's your first red flag that you have to carve it out. Now, I didn't have to carve out the B, but what that means is I've got a non-separated occupancy. So whatever the stricter code requirement is for a fire alarm, for sprinkler, for all that good stuff, is not going to just apply to the A2. It's going to bleed out into the B. It's going to bleed out into anywhere that I haven't separated it. So in general, it's a good idea to carve out kind of smaller subcategories just so you can confine those more restricted requirements just to that piece of the building. Does that make sense? Okay, so you can go to document 7, please. So you all have this document, and I'm going to explain the process of how I got to a type 2A for Boynton. And then at the end of this, I'm going to have you guys run through one calculation. And it should only take less than 5 minutes. But what I gave you in that booklet are all the tables that you'll need to do this. So in the very beginning, I said when you choose a construction type, you want to go after the lowest construction type that you can get. So if anybody can tell me if they look at 3B in their table with these square footages here, this is the total first floor. Can anybody tell me why I didn't even bother doing a calculation on a 3B based on that number? I'll give you a hint. It's going to come down to the tabular area calculations that if you were to pull that calculation up on that table, why don't you pull up document 4, I believe it is. No, I'm sorry, it's 5. If you were to take a 3B and come down to an R2, it's 48,000. And now go back to that other document 7.
Oh, you want document 7?
Yep. So right off the bat, if I plugged in those values, I'm not going to have enough square footage allowed to achieve a 61,000 floor plate or a 60,000 square foot floor plate. So I didn't have to waste time doing those calculations. So I went right to a 3A is one big building. So I got a 302,000 square foot building, and these are the square footages for each floor, broken out by occupancy. So it's really not complicated. You look at that chart for 3A, you pull out your tabular values of 72 and 24, and then take that frontage increase, which I showed you as a 0.52. Now, in this example, and I put in a little disclaimer, it actually bumps up to 0.54 because I showed you how to do the frontage increase for the left and the right half of the building. You'd end up doing it as one big building. So that's why this is a 0.54. So you get this value you're allowed to have for an R2, for an A2, S1, and a B. And then if you scroll down, now we use that formula that I just shown you for a multi-occupancy, multi-story building. And this is the value that we just determined up there, taken right out of the code book. Here's my 32,000 square foot value that I have for the entire building. Divide that out, and this is your ratio, 0.38. So for your first floor, you get a unique ratio for each occupancy. When you total those up, they have to equal, would be less than 1. So we passed, right? So you have to take it the next step and do that for all your floors individually. No floor can be greater than 1. Fine. But then when you add up all those values, you cannot be greater than 3. So this building has failed. I cannot do it as a a 3A unless I do a firewall or I bump up the construction category. So go down to the next one. And this one will be much faster. So now I've done it. There's some history here too. I'll do it as a 2A, no firewall. This is one big building. All I did was bump up to the next level of construction classification. You do that same process, take out all your values, get down to the bottom. First floor passed, every floor passes. Again, it fails. It's too big of a building. So that drives the decision. Go to the next one. I'm still going to go after the lowest category that I can, which is a 3B, but now I've cut the building in half. And exact same process, the only difference is you have to run one side of the building, the other side of the building, and when you get to the bottom, it passed on both sides. So this passes as, what was this one, a 3B? So this passes a 3B. Why did I end up with a 2A? So in this particular case, the owner wanted to have a 3A. And I went and I showed him, so I can do this as a 3B, take away all your individual protection requirements, a lot of fire ratings go away. If you wouldn't mind flipping back real quick. Actually, just go back to the Revit model. Right in the center. Right here. So I just showed that I can do this as a 3B. 0 rating on the structural frame, 0 rating on walls, floors, ceilings. Why the hell didn't I do that? Well, this owner, when I proposed it to him, he said, "Nah, we always just protect the columns." That's what we're gonna do. So he decided to do it as a 3A. And then I looked at that, and knowing that when you're dealing with a type 3 construction, normally it's CMU on the outside and wood on the inside. We have metal on the inside. Okay, is that big a deal? No, not really. But since we had metal studs, and when you look at a 3A where we have 1 hour, 2 hour exterior walls, 1, 0, 0, compare that to a 2A. The only difference is a 2A actually has a less strict requirement on the exterior walls. Really doesn't make too much of a big deal, but we're dealing with a senior population. They're slower to evacuate. This is an insanely long building. So I made that call to go from a 3A to a 2A because it's not going to add any cost. Knowing the materials that we're using in this building, it's just an extra level of belt and suspenders because of this particular population. So we'll go one more, back to that 07. And then keep on going down.
Joe?
Uh-huh.
I was
sorry.
just curious if you can go back to that table real quick. So I did notice obviously that on the type 2A you have column protection, and type 3A you do not. So is that the difference between the 2 hour and 1 hour on the exterior?
Nope.
Is that kind of a wash?
We'll get to that one in a minute, but this basically is right out of the IBC, and you have to modify it each time, whatever code you're in. But all these values, guaranteed, are going to be the same. They don't ever list this out. They just say primary structural frame. We've listed this out specifically because 50% of contractors screw it up.
Okay.
And they don't understand that you have to individually protect your column. So that's just throwing it right out there.
Okay.
And if you, which document is it? When you go back to the folder, file explorer at the bottom. Just as an example, this one here. No, the one underneath, 13. Sometimes you can get fancy with it. Like in this case, this happens to be Buckhead, where the primary structural frame starts out as a 3, but if you take other exceptions, because of high rise and whatnot, your primary structural frame reduces down, but your columns have to stay where they are. So that's broken out separately there too, so they don't screw it up. Back to fun calculations.
So they're not lumping in your columns as primary structural frame then?
They are,
Okay.
but the exception allows everything but your columns
Okay, so
to
girders and
be
beams,
downgraded because you're building a bomb shelter, what I always call it, and the building's not going anywhere, so they give you some breaks on your beams and your other structural elements because of that. When you go up to a 1A or a 1B, you higher level sprinkler just across the board. So next one. So 2A, I'm not going to bother going over, but this is how I ended up as Boynton, and it passed and comfortably passed. And now we actually have a VE exercise. He wants to save a little bit of money, even though it was really his call to still continue to provide individual protection on columns. But if you go to the next page here, I gave you all a blank section here. And I know a lot of you have already done this, but I also know a lot of you have not. So I thought we could take a couple minutes and fill this thing out just to drive these numbers home. All right, so finished or not, I don't think we need to really go through. Todd can scroll to the next page. And basically, there it is. Those are your calculations that you should have gotten.
So where did the 16,000 come from?
So that's taken out of this equation, 5.3. I gave you
Okay.
5.1, 2, and
That's
3,
what it is.
which are multi-story, single-story, mixed occupancy. So that's your tabular area and your non-sprinklered value. So you gotta look. So you take your non-sprinklered value because they figure that's a building with no fire protection on it. So we gave you a frontage increase. So we're going to let you take that perimeter that you provided and multiply it by what a base non-sprinkler building would be. And this is basically the additional square footage you get. So the higher your frontage increase is, gets calculated by that base building, and then you get to add that. So we got an extra 5,000 square feet, or in this case, 8,300. So what you would see, if you scroll down to the bottom and do all these numbers, is you work out your ratio. We pass in every scenario. It gets a little close, but we still pass on both left and the right half. So this is going to end up going back to the again and say, hey, remember when I said let's go down to a 3B construction? Well, why don't we go to a type 2B construction? Because that's going to allow me to get rid of all his individual protection of his columns, any of those beam ratings. In his case, it's really not that big a deal. The only thing it's going to save me, and I'll get to this next, when we talk about individual protection, that protection is going to go all the way up, all the way through the ceiling to the underside of the slab. So he could delete that extra drywall and not have to worry about fire caulk around or even dampers because he doesn't have any rated walls that he's got to penetrate. So we'll see if he ends up taking that path or not. So there's another way we could have done this if you said, I don't want a firewall. Anybody think of how we could have even gone extreme and eliminated that firewall? Not with separated occupancy, but it's more of like, you're saying build a bomb shelter.
Like construction.
You go up in construction site, then he can save the money on the firewall. But now he's spending a lot of money on the 2 and 3 hour ratings. But it allows, basically, if you have a 1A, go to was it 15? It was 002, 13. So Buckhead was pretty simple because now here's one of those examples where they didn't say chapter 5, chapter 6, so they get moved around a little bit, so I have to find it. Down here. All those calculations that we just wasted time doing, unlimited. I don't have to do anything because, it's a bomb shelter. Alright. So back to the Revit model, please. The next section, we're under chapter 5 still. We already got through the calculations. Something else I don't have listed here because they don't apply, but if you follow this roadmap as you're going through doing your code study, it will take you right through the code. There's horizontal building separation lines, there's podium slab, which you're dealing with on Lantern Hill, and they're going to drive other constraints and other triggers. So part of this exercise was determining, do I need a firewall? Kind of related to that is, do I need expansion joints? So if you want to zoom out a little bit, this exercise clearly showed I needed a firewall. And it happened to be, this is unique. We had a parking garage building that we had nothing to do with. It's not built yet, but it's technically going to be existing before we build our building. So if we were doing this, we'd have to treat it as if these were two concurrent buildings. But because this is existing, then I can take some trade-offs, and I'll get to that in a second. But it was just logical to put a firewall right down the center and separate that into two heads. Now, expansion joints, a lot of people have heard me say, never, ever, ever expansion joint next to a firewall, because you're dealing with a 90 rating here, and I'm sure everybody knows a firewall has to be structurally dependent. So none of this structure can bear on it, or vice versa. And if it does, it has to be able to, like a fire cut wood joist, it has to be able to burn away and fall out of that wall without tearing it down. So how do you put a door in this wall if you also put an expansion joint on one or other side? Because that door has to stay intact if this side of the building falls down. And then you got an expansion joint in there. So I got a door that has to be permanently in place, but I've also got to allow expansion and movement to happen at that exact same opening. It's really a mess. So we've located them straight through here, and we were strategic with where we located them so that we tried to stay away from corner where possible. And then we had another one way over here that went straight through, and then we hit a corner here, but it's a very easy corner. But whenever possible, try to hit it where it's a straight wall. So you got a 180-degree wall on either side of it, and you're not dealing with all these extra conditions. If you go to 260, please. And then you'll see it compounds when you get up to the roof level. Zoom in down here. You get a firewall that can't have any openings on either side of it, and that usually projects to the roof unless you're taking some code exception, and then you get this kind of thing going on. So if you can stay away from those corners wherever possible, you're going to make your lives so much easier. What's next? So you determine if a firewall is present. Next thing, if you're doing an occupancy for AL or memory care or whatnot, look at your smoke barriers and your smoke compartments. All right, and I think move on to chapter 6. Back to that. So once you've gotten back to this point, and that's the roadmap tells you that, once you've gone through, you have to, and when you're way back here, you have to first pick a construction what your gut feeling is. When you run through this thing, you run through all your calculations. When you get back to here, then you have to update it and confirm what your calculations tell you and make your adjustments. I'm going to breeze over this real quick. This is basically just taking it right out of the table. It's your fire resistance rating based on fire separation distance for your exterior walls, which is, if you just follow through the code sections, it'll tell you how I got to 0 and 1 in that case. Now, let's talk a little bit about fire separation distance, which you have the article there. So some of you may have cheated already, but if you have two buildings on the same lot and they're 30 feet apart, what's your fire separation distance?
Oh, fire separation distance.
Fire separation distance between those two buildings on the same lot, and they're being built at the same time, like Lantern Hill. And I'm not picking on Lantern Hill, it's just,
Well, isn't there an imaginary boundary line in between, so it's 15 feet on your side?
It depends. It could be 15, 10 feet,
That's
20
how you
feet.
draw
You said it's
For-
imaginary line. You can put it anywhere
Right,
you
right, right.
need.
well, so we'll get to that.
Make
That's
it.
typically, well, so now you have the same two buildings, except one of them is on a different lot. And that building is 20 feet away. So you get two buildings 30 feet away. One of them's 20 feet from the lot line, the other's 10 feet from the lot line. That's your fire separation distance.
10 feet.
One is 10 feet and the other is 20 feet. So this little diagram, let me pull up,
Do you have balconies?
what is that? They count. That is, oops, 10. Zoom out on that. So that's just a graphic I put together that describes that. Two buildings on the same lot, 34 feet apart. This is your imaginary lot line between the two. Now, what Matt was starting to say is you can put it anywhere you want. Normally, the code will say this existing building, but let's just say I don't want any windows in here, and I planned it that way. I could put that line right here, 5 feet off if I wanted to, so that I could have as much open space and unprotected openings as I want. So if you go to the Revit model again, G110, actually G,
There you go.
so scroll down into this area here. One of the other reasons I chose a 2A for this building, I forgot to mention, this existing parking garage was a 2A, so it would also seem logical that way. But this parking garage is coming along here. I've got 11'3" between the two, and if you want to count this little column in the way, I've got 9'3". So with a fire separation distance, that's halfway between. If I just rounded it to 10 feet, I got a 5-foot fire separation distance. This architect had a conniption because it's an open parking garage, so it's completely open on three sides, and he's balancing his calculations, and he had a heart attack when he thought he had that 5-foot fire separation distance because he wouldn't be able to do his concept, and or I would have to pull my building back. So what Matt was alluding to, when you have an existing building, you can set that imaginary lot line wherever you want it, as long as you're placing it to maintain compliance with this building. So these sections of the code over here basically say that if I put it 10 foot away, then scroll over there real quick. With a 10-foot fire separation distance based on this compliance with those sections, openings in the existing garage are not limited. So I satisfied his needs. And I'm only 1'3" away from our building, but I planned on no windows there, so we're good. And specifically put this note on there. We call these breadcrumbs because I know I did that, but you don't know you did that, or I did it. And the inspector, when he's reviewing it, he's going to look at it and say, "You can't do this." And if you put your breadcrumb on your drawing wherever you left it, like here's another one for elevator hoistway, shaft protection. Opening protection not required because of that section right there. The second he starts to challenge it, he sees that, and oh, okay, and goes away. Now we go on to chapter 7. Everybody still awake? So here's the implication of that fire separation distance. I am less than 3 feet, so I am not permitted to have any openings, even if they're sprinklered. If I wanted openings, there's a whole, this table will expand further if you start protecting your openings and sprinklering them, but that's rated glass and all sorts of other stuff that you don't want to get away with or have to deal with, I should say. You basically follow this with your fire separation distance and move on. Now, if we want to look at 12, you can close 10. That is level, yeah, that's the one. So here's Buckhead again. We had an 8-story existing tower right here. And the initial design actually had this building like right, there was a pedestrian bridge right up against this thing. And then we, of course, pulled it back for other reasons, one of which is this fire separation distance. So if you could scroll in. Anybody who's seen this where you can see all these guys? Windows for 8 stories throughout that whole building. So we had to be really careful. Since this is existing, I can set this lot line where our imaginary line where I wanted. I set it at 5 feet based on a calculation that I can't exceed 25% of allowable wall area. So I did a calculation based on all these windows times 8 stories to figure out that I'm less than 25%. And that's because it looks like it's higher than that, but they're not as tall. So I don't have 25% of my wall area covered. So because I was real careful to do that, I don't mess around with this building. And now you can argue I'm 3 foot or so away at the column, but I'm almost 5 feet here. But I specifically planned no openings in that wall because I don't have to deal with protected openings and all that other stuff. So that's something you have to pay attention to on any project where you have an existing building. Okay. So who knows what individual protection is versus membrane protection and can thoroughly describe it? So I'm half joking. I know you all know what individual protection is, but most of the contractors don't. And if we don't call it out on our drawings, it can become problematic. So those of you who don't know what it is, if you go to your chart, your construction chart, table 601, it tells you have to have a 2-hour rated primary structural frame or a 1-hour primary structural frame. That primary structural frame is all your columns and your beams, and you have to individually protect the columns specifically. The follow-up sections of the code tell you that if you have a column, regardless of where it is, what it's supporting, it always, always, always has to be fully protected by drywall, concrete, spray fireproofing, intumescent, some form to completely encapsulate it. And not just up to the ceiling, it's got to go all the way up. And if it's holding up a beam, it's got all the bolt connections. That whole thing has got to be protected. And what you're trying to do is protect against a catastrophic failure. Because if that column, which holds up 4 stories, were to collapse, then basically everybody in the building is at risk. And they give you some flexibility on your beams, because some of them, if you have a beam that's got a column sitting on top of it that's then holding up more floor, that's a catastrophic failure because you get more than one floor plate that's going to collapse. And there's a couple triggers in the code. I'm not going to go over them now, but if you're over 2 stories high in a bearing wall or holding up more than a story of a roof, etc., etc. If all you're doing is holding up one floor plate, so you got a 5-story column and you got a beam that's here holding up the 2nd floor, and there's a bunch of joists that tie into that beam. If that beam fails, the beam goes away and just that section of floor falls out, it's not a catastrophic failure. So they let you membrane protect that, which means you have to basically conceal it above the ceiling and drywall, but you don't have to completely encapsulate it on all sides. So you just have to be careful that that beam is only holding up the 1 story and not multiple stories. And vice versa, make sure that you catch any that are holding up multiple stories, because if we don't put it on our life safety drawings, the contractor's not going to do it, and you'll get a change order for it. What else?
Joe, you typically do a beam protection plan?
If it's complicated, like the Lantern Hills, at least the ones that I've done, there's only a handful of columns and beams, so I'll do it right on my life safety drawings. But if you get one on the flip side, like Tyler's, where it's all post and beam, you don't really need to do a fire protection plan. You just have to say everything is individual protection. So you have to kind of weigh that yourself. If you get a project that just has pieces here and there, that's kind of hard to understand. that's going to warrant a fire protection plan.
Well, Laramie High School, I come from a career of type 1A, just spray the hell out of everything and you're fine. But on Laramie High School, I developed a fireproofing plan. And the fireproofing sub said that was pretty cool. Just identifying
Steve's
it.
using a hook to figure out which ones are protected, and it's really our job to tell them that. But you have to understand what the triggers are and where you get it right. So the next section is going to be, where did we get to? That's
Chapter 7.
where am I looking for? Oh, here we go. Your fire ratings, they're basically taken right out of this table. Your primary structural frame, bearing walls, non-bearing walls, 1 hour. That's how you start to populate this. And there's a couple one-offs in there, and that's why we leave these breadcrumbs for you that you're not going to find corridor fire resistance rating in Chapter 7. You got to go out to Chapter 10 and then bring it back. But we've consolidated them all in here. And you basically just go to those sections and it tells you half hour, 0 hour, whatever the case may be. And then you get into incidental uses. And a lot of people get hung up on these because particularly when you have an NFPA project involved, it's pretty easy to go to table 509, which I think I put in there, and pull out, furnace rooms over 400,000 BTU, fire pumps. That one is a little bit more hidden because it's in chapter 9, and then generators always get missed because it's in NFPA. It's not in IBC. And if you could go to GO214.
Is it in the
It's in the PDF file. It's going to be the buckhead. This guy up here. It's important you look at both codes because up here. Because if we stopped at IBC, we would have captured all of these. But once NFPA is triggered, you got to look at each one of these sections. Chapter 30 is apartment buildings, 32 is assisted, the one that exists in Georgia, but 18 is for long-term care and yada, yada, yada. Each one has its own list of special spaces that have to be broken out, and they get missed all the time. So they're there just so you're aware that there's always a lot of overlap between the codes, and you unfortunately got to find them all. The next I have is a life safety codes section, which is this sheet. If you zoom out, Boynton, though it was a big building, it's really an easy building. Buckhead, not so much. So this one warrants a life safety section, something like a Lantern Hill will, but not all the projects do. And what you're trying to capture is the vertical configuration, because the plans obviously show how the thing's broken up horizontally, but you got to capture, here's your podium slab and what code separations you're indicating where your different occupancies are. And these are 2-hour slabs versus 1-hour slabs, and how the vertical circulation ties into that. So you'll have to kind of make that call on a case-by-case basis. Unless it's got something complicated going on, don't waste time with it. So we've identified we need a 1-hour wall, we need a 1-hour slab, we need a 4-hour CMU wall for the generator. So how do we find these rated assemblies? This is just a sampling that I put together. Everybody knows UL, right? Mm-hmm. Everybody knows how to find an assembly. There's a chart in the beginning that tells you whether you're looking for a column.
I just noticed it.
If you're looking for a floor ceiling assembly or a wall, here's just an example. U is a wall, U419, and it tells you exactly what has to be done. So everybody knows 1, 2, 3, 4 hour. It's pretty straightforward. What's the STC on this wall? How do you find that? UL doesn't care about STCs. So keep on going. I think I might have given another example first. I cut all these pages out of the printout, but you'll just have to keep going.
Should have bookmarked it for me, Joe.
Well, I ran out of time because somebody came in my
Keep going.
Yeah, this is all one assembly. This is a good example that shows what kind of alternate compliance paths you have. Let me stop there. Because you may have one wall assembly and seems pretty straightforward, but you can use resilient channels, your hat track, or different layers of drywall, and lots of different options. And unfortunately, you've got to pick one system and stick with it on your documents and not let the contractor swap out and put pieces together because it'll come back to haunt you. What about a concrete floor slab or a concrete column? There's no protection on it, right? It's not going to be in UL because UL is all about drywall or spray fireproofing or intumescent. So there's nothing that you'll find in UL. Here's an example in IBC where they have a bunch of prescriptive fire protection ratings. In this case, this was my concrete column. I think it was this one. And you kind of have to educate yourself a little bit to know what kind of concrete you're using. And then it'll tell you for a 4-hour rating or 2-hour rating what kind of coverage you need to have on your steel reinforcing. So like Buckhead and Boynton, it's using prescriptive rating because there's just no UL for it. So keep on going. And here's where we get into the sound. And GA, USG, they all have, and we have some of these manuals in the office. But for any kind of residential occupancy, we need an STC 50, which is sound transmission class. So if somebody's got a TV really loud, you can't hear it on the other side of the wall. Usually that's more important with walls, but it does apply to floors. So this is telling us that for this assembly of resilient channel, we get an STC of 50, and there's your sound test to prove it if you wanted to.
Can I make a comment on STC?
Mhm.
It's come up in my previous terms. STC is a rating based on a certain noise frequency, which is typically based on normal speed. It does not cover the lower wave band. So it will not, higher SEC of like say 84
It's a diminishing return.
it's a diminishing return when it comes to the bass. So if you have a situation where there's going to be a lot of bass or a lot of impact noise like that, STC will not help you at all.
Well, that's when you go to the next one. Firm like these guys, Kinetics, they do, and I cut all the paint. Well, actually, I didn't cut it out here. This is a concrete floor, and they're telling us they can get us an STC of 50, and now tied into their base is IIC, Impact Isolation Class. So if somebody's walking on that tile floor with high heels, you can hear that. We actually had at Lantern Hill, was 3 stories in the air. It was an assisted living dining room, and they would slide as they got up from the table, slide the chair out, and they heard down on the first floor those chairs sliding across the floor through 3 stories. And they changed to a different kind of runner on the chair, and everything was fine. But that's what your IIC does. This one's a little bit harder to really get your head around because there's not too many assemblies that are published. But in this case, they got an IIC of 52, and they give you a delta of 24. That just means the difference, if I understand it right. The base slab, if you add this material to it, it'll give you a delta of 24 additional points to add to that slab. That's one that we get burned on for issues just like that, but they're harder to find those assemblies. And that's where on our unit plan templates, especially with all these wood buildings with a gyp topping slab on it or a hambro with a concrete floor, there's a sound mat that goes underneath the hardwood floor, and it has to turn up at the edges so that the sound doesn't get flanking sound out the side of that slab, transferring the walls, etc., etc. So this is their test. You can go really fast past that.
Joe, is Kinetics the third-party consultant, or were they the manufacturer?
They're
of
a
the-
manufacturer, but I go to them quite a bit because
So they do the underlay.
What's that?
Did they?
They have an
did
under. They have an underlay
Okay,
there
that's
in Kasai because it's
Same.
the one they use all the time.
Yep.
So who knows what a through penetration fire stop system is? Okay, do you know how to find one? UL details of walls and floors, they're pretty easy, pretty straightforward. But most people don't know how to find I've got a concrete floor and I've got a PVC pipe going through it. How do I find an assembly? Because it's UL fire resistance direct. It's the volume 2, which we have floating around the office, but they tend to keep getting thrown out for some reason.
Why are you looking at me?
I
don't know anything about it.
in your pile of stuff there. But in any case, you cannot flip through. If you're looking for a wall, you could flip through page by page and find something. If you're looking for a fire stop assembly, there's not a chance in hell that you're going to flip through and find it unless you understand how to use the keys in the beginning of the book, which I would show you, but I couldn't find the manual. So in essence, back up here, it's a W, an F, or a C. W obviously is a wall, or F is a floor, and a C is a floor or a wall. The L has to do with what type of assembly that you're going to be penetrating. And these numbers, 1,000, 2,000, 3,000, they relate to the type of penetrant. In this case, I think it was conduit, non-metallic cable. Yeah, one metallic pipe. So it tells you what you have to do when you penetrate that 1 inch wall that we called out on the last safety plan. And it'll tell you for a wall assembly, basically, usually it'll say any U300 or any U400 series wall. So it's pretty forgiving in that manner. Keep scrolling down. You do construction administration, you will have an inspector challenge you on one of these at some point on every job, regardless. That one's a bank of conduits. And the important thing here is go up to the top. So does anybody know what these are? F, T, and L, what those mean?
That's what I like.
So for a wall, you get a 1 inch wall, and of course the thing's fire tested for how long it takes to go through it. For penetration, it's a little different. Your F is for fire, your T is a temperature rise, and then the L is really important. That's for smoke. So as that thing heats up at ambient temperature, go up to the other one, because this one says C item 4, but the other one, this one tells you specifically at ambient temperature, it's going to let 1 CFM per square foot of smoke get through that. And when it heats up in a fire to 400 degrees, it's still less than 1 CFM per square foot. So when we're specifying smoke barriers, we have to pay really close attention to these kinds of assemblies that specifically have an L rating. Because if you pick one that doesn't and you install it, there's a chance you're going to get unintended burned when the inspector questions it.
So, are we specifying these, or are we reviewing what our consultants are specifying?
Both. So I always start out by picking them just so that I'm making sure that we're paying attention. And if you go to the next one, everybody always forgets showers and keep going. Showers and toilets, what do you do with those? Because they also have to have a specific rating, and everybody always forgets them. The contractor doesn't even, half the time they don't submit them. So this is just our kind of belt and suspenders, making sure we're doing our due diligence.
So is our fire stopping spec robust enough to address these?
So what we've done in the past, and maybe it still happens on some projects, where these UL assemblies, to answer your question, no, the fire stopping spec is not going to be able to handle all these unique conditions, but we've traditionally put these on our drawings. So you get
Jersey
fire.
requires it.
Well, they never did when I worked in Jersey, but if it's something new, then if you have to do it, then put it on the drawing. But do you know if they'll let you put it in the book spec?
I didn't have this specific information in the book spec, but I suspect, having dealt with them for the last 3 years, they would require a month.
Well, we're going to talk about jurisdiction that doesn't require it specifically. Our standard, unless they require it, is there's a process, and I outlined it in here, that determine and list your chosen fire-resistant assemblies on the drawings, and then save that PDF right off of UL to Design Resource Code Info UL assemblies. So it's part of your code information for that project. And those 8.5 by 11s get included as supplemental information in your book specs, so we don't have to take time taking screen clips of a 20-page assembly and 10 sheets of drawings, unless they require you to do it. Any other questions?
Do you find that we on projects are using like a transit frame type spec, where we have done those in the past, like through wall, where the one above and the same one where multi-pipe penetration, multi-cable, or anything like that, where it's basically an assembly.
I haven't used that, but it's up to you if you want
Gotcha.
to pick it out. What I see a lot of times is they're now requiring us to put them on the life safety sheets as a deferred submittal. So I don't technically have to include them other than the number, which is what I did on Boynton. And contractor will have to submit it to us. We review it, stamp it, then I've got to send that into the jurisdiction and they approve it. Getting to the end. So back to G110, and I read it. Chapter 8 can breeze over real quick. It's more for interiors, but interior wall and ceiling finishes, floor finishes, and decorative trim. It's information literally taken right from these sections. You just have to modify it based on your occupancy and construction type of your building. But we put all this stuff there to make it idiot-proof. Tells you what a class 1 and class 2 requirement is. So if interiors picks out a carpet or a fabric that just looks a little suspicious, if it's not meeting those requirements, then you can't use it. Chapter 9. This is on here more like the cover your butt type of stuff. So this is about stain pipes. Any building that has 30 feet above fire department access is going to need a standpipe, which we typically do indicate on our drawings, but it's the fire protection subcontractor who's going to show that. It's just us to make sure that he doesn't put that pipe right in front of the door and it messes with the clear width requirement. This next one, hose connections, is on there so that we don't get burned, because whenever we have a horizontal exit, firewall, we have to have a hose connection within 130 feet on either side. So I'll explain that. You have to have a hose connection on either side, except where adjacent floor areas are reachable from interior exit stairway hose connection by a 30-foot hose stream from a 100-foot hose. So if you can just go down on the page. So we have a horizontal exit right here. And my nearest standpipe is right there. So you do the calculation, they connect the hose here, come out around the corner, just like they would, not, as the crow flies. So 100 feet, and then they have to be able to hit that door with a 30-foot stream. So I can do it in that case, but I can't here. So that's what this little guy is here, is a very expensive hose cabinet.
Sorry, I was showing them. Hose cabinet.
Yeah, next to the fire extinguisher cabinet. So anytime you have a firewall, you got to check that 130 feet, because that thing times 5 stories. I have actually had it where I had to put it on both sides of the wall. And it's expensive ag. So back up to the top. And then fire extinguishers, I'm not going to go into detail on how to calculate it, but if anybody wants to know how, I'll be glad to tell them. It's based on there's class A, B, and C fires, and then K fires for kitchens, but it depends on what's going to burn, what you have to provide. And the ratings, they sound a little bit goofy, but it'll be 2A10 BC or 4A80 BC. What it's saying is there's 4 units of the A suppressant for a Class A fire for a 10 of the B and C or whatever it happens to be. And you just have to make sure that they're spaced around around the building so that you have enough of them. Enough said. And this last one, emergency responder radio coverage, we're getting hit with that quite a bit now. We put that on there because there's not much you can do at this moment other than engage your electrical engineer in your local jurisdiction to find out what their requirements are. Because you can't physically put in the system until the building is built, because they can't go out and test it now because, yeah, they got a great signal, there's nothing there. But when they build it and they're on the first floor trying to get to somebody on the fifth floor through all the concrete, then their signal degrades, so they have to put repeaters in. And you need to determine in the beginning if you have to put the backbone for that in. So fire-rated conduits that go through your building and very difficult to add after the fact.
And that can be a big ticket item, even on a small 65,000 square foot Sunrise facility. In the jurisdiction you're building it was $220,000. It's $4 a square foot for some signal repeaters, boosters. And like Joe said, if you get because all the Sunrise projects, they have hardly throughout 99.9% of their buildings. So how do you install that after the fact? Because the fire department's not going to come test until almost the furniture's in. Well, how do you do it after the fact? Well, you put junction boxes and conduit in your ceiling. I mean, that's 60% of the expense. And the testing, and then the cabling, and the head-end equipment. How many different frequencies those first responders communicate on tells you how much head-end equipment you have. So it really snowballs into a big deal.
So
Not as
sorry.
not as big a deal in a wood frame building because it can go through all that, but when you get concrete and then the thicker 8-10 inch thick slabs, then it really starts to become a problem. 10 means of egress. So quickly here, everybody knows, your required egress width through stairs and other than stairs, i.e. doors. And these numbers will change a little bit depending on what occupancy you are, what code you are. Usually 0.2 sometimes can get down to 0.15 and 0.3 can go down to 0.2. You have to verify between both IBC and NFPA if it's applicable, because NFPA is usually stricter. So what that means, if you go down the bottom to the plan, this guy we've modified a little bit, and that the arrow is telling you what your egress direction is, and then it'll tell you egress width required 12 inches. So if I had 98 occupants that were going through this stair door, or they're going straight through, but they're going through the door here. So I had 59 occupants. When you divide that by the 0.2 for doors, you should get 11.8 inches that's required. And here's where a lot of people miss a bit. Inches required are 34 inches, even though that's a 36-inch door, because when the door's open, it's the thickness of the door and the stop on the other side. So almost every one of our older sets of drawings had 180 people that we could fit through there, but it's actually 170. And you do the same thing for stairs down here. What we used to do was, it was a little ambiguous. That little arrow, let's go down to, sorry, I'm telling you to jump all over the place, this stair tower. Yeah, here you go. It's a little bit confusing where this arrow would be pointed on either the door or the stair tower, and which is it? Is it the door or is it the stair tower? So we've broken this out, that this arrow is on a component. It's on the door. It's always on the door. And then the stairway widths, because that tells you I'm capped at 170 people through that doorway. But if I go over to stair 4, which is calculated differently, that stair 4 is a 48-inch or 46-inch wide stair at 0.3 inches per occupant. I'm only allowed 155. My life safety plan said I get 170 people through there. Well, shit, you got a bust. And now I've taken a calculation on here. If you're over 44 inches, you can follow that equation and it allows me to bump up to 155. So you have to be really careful with that, which is why we've broken it out now separately, because typically the width of the stair, it doesn't change from top to bottom, 155 period. And then this tells me I'm only putting 32 people through there. So be careful of that. Egress paths. A lot of times we get burned on this. So we have these Revit components, I'm sure everybody's used them, and typically you start in the most remote point of a unit and make sure that you follow an actual path, not just go in a straight shot through the walls and everything. You have to, I mean, you could make the argument that I went right through the bed. I'm not going to get that hung up about it, but that path tells me I'm 233 feet, and the other section up there tells me how much. I think it was 250 or something I was allowed. 300? 250. So I'm allowed 250. You think you're all well and good, but go back down to it, and FPA 101 comes in and screws it all up. Because they calculate it from the face of the door. They give you a distance that, let me back off. It's, I think, 150 feet, was it? No, 200 feet in this occupancy from the face of the door to the exit discharge. And then it's like another 50 feet they give you within the unit. But I have had it where we were compliant with this path, but it was 210 feet to the most remote unit. And it's a big deal to fix that if you go too far.
Is that why you ran 2 lines ago?
That's what we're going to make as a new standard. Any NFPA project, you got to show, and I did it on both sides, your worst case NFPA path, and then the others are just your typical IBC paths because they're a lot easier to comply with. And that will save you from a lot of headaches. Okay. And then dead end corridors, everybody knows what they are. If you just go to 16 real quick, I'll just give you 2 ways to get around it. So this was go in here. Whenever if I got a 50-foot dead end corridor, and I'm that close to it, you need to put that on there because guaranteed you'll get a question by your inspector and that'll take it away. And then here's a strategy that you can use when you have that situation is just put a storage room at the end. Sometimes you don't have a choice. If you plan on it early enough, you pick a unit where the door is farther down so you can recapture that, or even have a unit that comes across the corridor. But always put it on your plan so that take away his ability to challenge before he even asks the question. And then go to 15. And another way to do it is up there, where longer than this was in memory care, so it was 30-foot dead end corridor starts here and goes all the way down there. It's much longer than 30 feet. But you can take code exceptions that say if your corridor width, I forget the exact terminology, but your length can be extended by 2.5 times the width or something along that line. So it lets you get a little bit longer. Now, technically, if the guy wanted to be a hard ass, he could say that this door, it's really the least width of the corridor. So I would have to pull this out a little bit. So that's no longer the least width of the corridor. But there's ways around that if it came down to it. Emergency escape and rescue is real easy one. Almost all R2s need it. Your assisted and memory care don't. So for Boynton, I don't have a single emergency escape and rescue window. So how did I do that? That's because every single bedroom has a door to a balcony. So that's my emergency escape and rescue opening, and I've got fixed windows. For Buckhead, I don't have a single one, and it's all R2 in the tower. Well, it's a high rise, so I took a provision that eliminated it in there, but it's something that you just have to watch out for. And what else do we have here? The last piece is an important part. think we'll have just enough time to finish it. You can close, actually leave that one open. Go back to the Revit model, please. Occupant load tables. This is something new that's showing up on our template, and they tie directly into these tags that are over here. So this A2 occupancy, kitchen 163, is right here. Now, normally these are taken out of Chapter 10 of IBC. In this case, both Buckhead and Boynton required it to be out of NFPA 101. Almost identical, but there are differences in how you calculate it. So this kitchen has 624 gross square feet, which is right there. And you divide that by 100 gross, which is your load factor. And it tells you I got 6 people that are in that space. So 6 people, and I need 1 exit from that. As opposed to some others, this happens to be the whole residential area. It tells me I have 133 people in that residential chunk, and I need 2 exits. So we want to get this automated. You'll find it in the template. It's just not quite there to do the math for us yet. It's easy to calculate your gross square footages. Business use, just divide by 100, and gross is just one big rectangle and tells you need 25 people. Where it gets tricky is if you could go to like these 15 net spaces, the working area calcs. And this is where I have all my boundaries in here. So if you click out here, you'll find you can kind of see it, this gray area, that's a specific occupancy that was done. I think I did them as a B here, but if you click on this one, I'm taking out whatever I can. So the columns, sometimes you can take out other fixed features. The code will let you do that. But it's important when you're taking a net calculation that you subtract out everything that you possibly can. Because if you go back to the 110, when you divide, you got 2,500 square feet divided by 15. Every square foot counts, because you could be talking about 20 extra occupants that you then have to take out. So this is going to be required on every project, and it's in there as a base, and you just have to copy stuff around until we get it automated. It's going to tell you how many occupants you have in the total building. But with this information, and here I'll breeze over it if you just move this thing over, it's up to the manager to figure out what the egress flow is. Because I know basically how many, 61, 46, 25, how many people are in each of these spaces. And I know that I got an exit here, and I got one here, and I got one here, and wherever they happen to be. But it's really up to the manager to decide logically if somebody's exiting this space. Some of them are going to go out here, some of them are going to go out here, and we can break that up. And I'll give you a tip to always save your calculations, because there's no way a month down the road you're going to know. And it's happened on this project. It's the first time ever where the guy came back and said, no, this courtyard, I don't want you to go back in the building. They always tell us to do that. So now I have to reshift my numbers, and I know I started with 81. I just have to go back to my file because I know exactly how many people I was taking through this door, down the hallway, and out the stair tower, and I just have to redistribute it. Don't save those calculations. It can be a mess. Any questions on that? Because that's a lot of work that's summed up in 5 minutes. But that'll take a half a day at least to do those calculations. So if you go back to that working area calcs, every space is carved out, and there's multiple layers on here. I mean, there's a boundary here that captures all of the B occupancy, 5,800 square feet, which is my initial those first calculations we walked through. That's where I calculated all those areas, so I know how to go back to them. But then within each one of them, there's another boundary that's calculating just the occupied space. So the toilet's not included, the columns are not included, or at least not supposed to be included, unless that's a gross and not a net calculation. So each one of these areas was carved out. I'd love to do it with rooms if we can take the math away, but it's all there, so it's easy to go back to and tweak it. So the last part that ties into that, a real quick one, go back to 110. This guy right here. So your accessibility is going to vary state by state. You're always going to have federal version, Fair Housing Act that you're going to have to deal with, and then some level of local or multiple local jurisdictions. In the case of Buckhead, there are 3 accessibility codes, and Boynton there's just 2. So I think a lot of projects have used this little ADA symbol. So now this unit is called mobility. And then thanks to Matt, we have this little symbol taken right out of the accessibility code, which is for the communication features, the visual flashing doorbells and controls that are a lot of speakers and whatnot. So we want this symbol to be used on all of these types of units, and it's a model symbol. So if you actually went to like go over here to A2, which one? 214. It's grayed out on the life safety plan, but when your consultants actually start to do their work, they're black, so they jump out at them in combination with the title. So they've got no excuse that they didn't provide those special electrical features there. And then go back to, you can close this one out. Down here is accessibility legend. I think we're pretty much doing it anyways. We've always had a unit schedule. The problem I've been finding is that the inspectors want to see specifically, well, where is that unit? And they don't want to find them on the floor plan. So now that's where this guy comes in. It says exactly what space it's on and confirms your accessibility count, whether you got mobility features, communication features, or both. So it should be pretty straightforward. The last part then is chapter 29. It's up a little bit higher. There's a table right in the center. This guy here. So minimum plumbing facilities. This one's kind of a gray area. Is it our responsibility or is it the plumbing engineer? Well, it's his responsibility to do the calculation, kind of, but it's really our responsibility to make sure we've had enough plumbing fixtures. So just by that nature, it's kind of our responsibility. So this will vary based on what occupancy you are, but just go in and update these numbers, whatever they happen to be. And now, unfortunately, you gotta go to 15.
That's 15.
That is 15. We didn't have it in the template at the time Buckhead was done, but this occupant load table that I just showed you tells you how many people you have. So this 135 people, if you come over here, that space, now this was done by NFPA, the occupant loads calculated by NFPA 101 because the state mandated it, but the plumbing counts are done by the International Plumbing Code because they only care about fire and don't care about plumbing. So although this is assembly less concentrated, it's an A3 occupancy in plumbing code, and you take that whatever I said, 300 people, and basically apply these factors, or the factors that were in that table, 1 per 65 or 1 per 125, and that's the number that you get for men's and women's water closets, men's and women's lavs, electric water coolers, and then the janitor's closet. It's really just one for the whole place. It's a little more in depth than that, but not by much. So what you end up having to do, and this is going to be automated very soon, that these total up, and it gets to 1.792, so we have to provide 2 fixtures, and we tell them we provided 2 or whatever the case may be. Yeah, I guess I'll leave it there. It can get a little bit fancier, like this says down to level 1. When you're dealing with a multi-story building, you don't need a janitor's closet on every floor. You don't necessarily need toilets on every floor. You're allowed to go up 1 story or down 1 story and share some of those fixtures. And this one gets really complicated with that, so I'm not going to go into the weeds on it, but it just will confirm at early DDs that we've got enough plumbing fixtures, and we're going to have to add them later on. So, and that's really it. We have a minute or two. Does everybody know firewall, fire barrier, fire partition, smoke barrier, smoke partition, all those differences?
Let's hit it.
What's that?
Let's do it. After this.
So obviously, firewall is structurally independent. It's got to go all the way up, usually through the roof, but you can take some exceptions to stop it. But it cannot come down for the time period, 2 hours, 3 hours, whatever the case may be. And it's kind of the worst case scenario. You step down to fire barrier. Those are incidental use separations, occupancy separations between A3 and B, whatever it happens to be. And that's whatever the rating is, that wall has to go all the way up through the ceiling to the underside of the deck above. And if you have a bar joist and that partition is going up and interacts with the bar joist, you got to scribe around the bar joist and fill it in or do something to make sure that the barrier is continuous, both horizontally and vertically. And then a fire partition is, if this was a 1 hour rated ceiling, I could stop that fire partition at the underside of the ceiling. The basic difference is a fire barrier is a barrier between something important and something important. So you cannot let that fire get through that barrier. Fire partition is usually just protecting structure. So I can have a fire partition with an unrated door in it, and if a fire starts over here, I don't care if it goes right through that open doorway on a 1 hour fire partition, because all I have to do is make sure that structure, that partition doesn't burn away. Then you step down to a smoke barrier, same as a fire barrier, because you're physically separating 2 things. That smoke barrier has to go all the way up through the ceiling and be continuous. The addition is now it's got to have that L rating on all your penetrations because it's doing smoke in addition to fire. And then a smoke partition is the least restrictive. It just has to not stop smoke. It just has to slow it down. And it doesn't even have a rating on it in most cases. That's it.
Thanks, Joe.
Sit on the walls. Yeah, I don't think I have anything else.